Hi, this is Ashit Goyal from BIMServe Education. In this tutorial, we learn about using walls to develop floor plans in Revit. This is the first part of the two-series lesson on building up floor plans in Revit. This tutorial is a part of Revit architecture courses available at BIMServe Education. Join a course for downloadable resources such as templates, assignments, and live instructor-led sessions. On completing the course, you get a downloadable certificate of completion. If you like this video, give it a thumbs up and hit the red subscribe button for new videos every day. Walls are one of the primary elements that make up a building. Walls can have multiple features. Many of these are visible, while many of the other ones are hidden within a wall. Visible elements may include external or internal finishes, sweeps and reveals, and cornices. Hidden elements may include structural core of a wall, insulation, substrate, and so on. Walls is a large and complex topic and can even become a complete course. I'll cover this in greater detail in a series of lessons later. For now, I'll use simple set of 230 mm and 115 mm brick walls. That will help us build our floor plan. These wall types are available in the Revit template that is available to you as part of this course. Let's open the exercise file understandingwalls.rvt. When we open this file, we see the two intersecting reference planes. One is a vertical plane while the other one is a horizontal one. The intersection is where we have set our project base point in an earlier video. You can find a link to this video in the information box on top right of this video, as well as the description box below. I'll select external 230 mm brick wall with the plaster on the internal face from the drop down. I'll keep all the properties as they are without changing anything. Notice the options bar. This indicates various options that can be set before modeling a wall. For now, I'll not change anything. Notice there are similar settings in the properties palette as well. I'll trace over the reference plane. Notice as I move my cursor down, the wall is centrally placed along the reference plane. Hit the escape button a couple of times to exit the line tool. I'll now draw another wall parallel to the wall that I just drew. Notice the blue dotted line along the center of the wall that I'm drawing. This dotted line represents what is called location line. It is showing the wall center because that is how it was set. Which is also the default value. I'll switch to a higher level of detail to display the wall structure and change the scale to 1:25 to make things a little clearer. I'm now able to see the wall structure, which displays a plaster finish face on the left side and brick core. I'll draw another wall parallel to this wall, but this time I'll draw this wall from bottom upwards. Notice this time the finished face is on the right side. I'll switch to 3D view and then type out VG on the keyboard to display visibility graphics. I'll pick the Imported Categories tab and then uncheck the checkbox that shows Show Imported Categories in this view, and then hit OK. Unchecking this hides the imported CAD file from this view and makes the topo surface clearly visible. Zoom in to see the two walls that we just drew. The exposed brick face is visible. I'll close all other views except the 3D view and the ground floor views. I'll then type out WT on my keyboard. This displays two views in a tiled format. Let me extend this wall a little bit and rotate this. The exposed brick face is on the inside face. I'll select the wall and then click on this blue arrow to reverse the wall orientation, such that the exposed brick face is now on the outside face. I'll make the ground floor view active and then type out TW command. This removes the tiled view and makes the ground floor view active. I'll draw a horizontal wall from left to right. Notice the location line is on the wall center and the plaster line or the plaster face is the bottom of the face of the wall. I'll draw another wall this time. I'll draw the wall from right to left. Notice now the plaster face of the wall is the upper face of the wall. So what does this show? It shows that Revit interprets the wall faces based on the direction in which the walls are drawn. Whether we are drawing from left to right, or right to left, or top to bottom, or bottom to top. For now, I'll delete these walls. And then reverse this vertical wall orientation. Now, while this wall is selected, I'll change the location line from wall center to finish face exterior. Note this little dot on the outside face of the wall. This dot indicates the location line of the wall. We'll discuss the significance of this location line in a later lesson. For now, I'll align the outside face of the wall and the vertical reference plane. Now, while the wall is still selected, I'll right click to reveal the right button menu and then select Create Similar option. Then draw the wall along horizontal reference plane. I'll draw from right to left. Notice the external brick face is getting created along the reference plane, and the plaster face is on the inside. So I'll draw from right to left to ensure the exposed brick face is on the outside. I'll click on the Modify button or hit Escape button and then type out TR on my keyboard. TR is a shortcut for trim. And trim and join the two walls. For now, I'll select this wall and delete it to draw a new wall, and this time I'll modify the settings before I start drawing the wall. The advantage of doing this is that Revit will remember my settings, and the next time I draw a wall, it will not ask me for the change in the settings. The location line is set to Finish Face Exterior. The next setting that I'll change is the top constraint from unconnected to the first floor. Notice the height is now grayed out, indicating the value cannot be changed here, and also shows a value 3204, which is the level difference between ground floor and first floor. Now we have two constraints, the base constraint and the top constraint. This will become clearer in a short while. I'll draw the wall from right to left and then use TR shortcut for trim to join the two walls. I'll use the TW shortcut to create the tiled views to display the floor plan and the 3D view. Note, the horizontal wall is shorter than the other vertical wall. This is because we set the top constraint of this wall as the first floor. I'll hit the Modify button. Now I'll select the other wall and change the top constraint to first floor here in this case as well. I'll cut a section. In this section view, we see that the wall base is right on the ground floor level, while the top of the wall is right up to the first floor level. These were the bottom and top constraint settings that we did. The word constraint implies that the wall base and the top are linked to levels. Their height is determined by the level difference between the floors, as well as the base and top offset values. This is typically how we model walls in Revit architecture, from floor finish level to floor finish level. We'll modify these offsets to see the difference they make. This concludes the lesson Understanding Walls. In the next video, which is part 2 of this series on using walls to develop floor plans, we'll learn how we develop architectural floor plans using walls. Thanks for watching. If you like this video, give it a thumbs up and do not forget to subscribe. Bye for now and see you in the next video.